Yeah, welcome everybody. Welcome here in the US and India and around the world. You're in many time zones. So glad you could make it to the inaugural annual conference of the Gupta-Klinsky India Institute. We're delighted to have so many of you here today. I am David Peters. I'm the faculty co-chair of the Gupta-Klinsky India Institute, and Amita Gupta will be joining. Well, it will be talking next. Wanted to give you a little bit of a background and welcome to the Gupta-Klinsky India Institute. We launched it in 2020 and really had a physical launch in India earlier this year. But to note, this is built on a history of Hopkins working in India since the 1930s and really continuously with academic organizations, government, civil society, really a long history of collaboration on research, education, institution building. It's really produced a lot of learning, a lot of action that have impacts from community level in India to globally. And it's really upon this that we built the rationale for this India Institute. Our purpose is really to bring together Hopkins faculty, staff, and students, and our alumni to work with our partners in India to improve society through research, education, policy, and practice. And this gathering is really an example of the kinds of things that we want to do and to build on. We've got some amazing scholars and practitioners today that we're going to hear from and hopefully have some great discussions. It also fits into our overall strategic plan, which has a number of core initiatives building on our current strengths in, for example, infectious diseases, maternal child health, and health systems. But it's also about moving into really some important areas for the future of India and the world. And environmental security, climate change are some of the critical issues facing our future, and not only of India, but again, really for the rest of the planet. So delighted that we can have this gathering today. Before I hand over to Amita, I want to thank Bob Bollinger and Nancy Reynolds, faculty who really helped stimulate today's conference, and really a full team who helped prepare this. Lots of great speakers and participants we're going to hear from. With that, I'll turn it over to Amita Gupta, the other co-chair of the India Institute.
Welcome, attendees across the globe. It's really, truly thrilling and exciting to launch our first annual conference and to have such a spectacular lineup around an incredibly important global issue. Nothing could be more prominent than the daily sort of news that we're getting these days with just unexpected events of climate resulting from climate change. And we really need the brightest minds across the globe to sort of problem solve and think about creative solutions for such an urgent issue. I think this is exactly what we sort of have envisioned and are delighted to see coming together with the bilateral partnerships that we have established over many years, and also are thinking about new faces and new names who are bringing some of the new ideas that we need to think about. I want to extend my thanks to all of you for making time. And I also want to thank our organizing committee, Tanya Chatterjee, Natisha Besra, Coulter Billings, Molly Bowen, who really behind the scenes worked incessantly along with our co-chairs, Nancy Reynolds and Bob Bollinger. This is what we want to see, and I'm thrilled to also be handing over the baton to our first speaker, who will introduce our keynote speaker, Dr. Benjamin Zaitchik, who is a professor of Earth and Planetary Sciences at the Johns Hopkins Krieger School of Arts and Sciences. Over to you.
Great, thanks so much, Amita, and thanks everyone for joining. It's my tremendous pleasure to be able to introduce Dr. Dalia Kirschbaum this morning. Dr. Kirschbaum is currently the director of the Earth Sciences Division at NASA Goddard Space Flight Center. In that role, she leads a group that has, I think, over 200 civil servants and well over 1,000 other Earth scientists, technicians, and contractors, all working in this unified mission to try to improve our understanding and ability to manage and improve conditions on Earth for all of its people. In that role, she's also been deeply involved in some emerging and really growing collaborations between NASA and counterparts in India. Prior to becoming the director this past year, Dalia worked at Goddard Space Flight Center for some time, rising to the level of chief of the Hydrological Sciences Lab, and doing some really exciting research all throughout her career on precipitation measurement from space, on landslides, and also on citizen science engagement on problems like monitoring and predicting landslide risk. Dalia holds degrees, started out at Princeton and then moved on to Columbia for a master's and PhD before joining NASA. And so don't want to take any more of your time, and just thank you so much for joining us, Dr. Kirschbaum, and look forward to your remarks.
Thank you so much, Ben. Can you hear me okay? Excellent. All right, so let me share my screen and we'll get started. Hopefully everything goes smoothly. Thank you so much for inviting me to speak. I look forward to talking a bit about how we are approaching Earth science at NASA. We work very closely with Johns Hopkins. We have close partnerships with the Indian Space Research Organization, ISRO. So I'd like to take you a little bit on a tour of how we are approaching Earth science, and in my role as director, how we've really worked to not only observe our planet, but harness and integrate that information for impact. So just to start, we have over 24 satellites and instruments with their instruments pointed down at Earth to understand our cryosphere, our ice regions, to understand our oceans, our land surface. And these are fundamental observations to allow us to understand Earth as an integrated system, but they are not possible without international partnerships. And so pretty much every satellite you see orbiting Earth, either over the poles or over the mid-latitudes and tropics, is a result of either an international partnership, a partnership with a university in the United States or elsewhere. And so these are critical to the success of all of these missions. And so if we look at Earth, as an integrated system, let's go forward. The four questions we're looking at in Earth science is: one, how is the global Earth system changing, and what causes these changes? How may it change in the future? And then how can we understand that in terms of providing societal benefit? And so the way that we do this is not only to look at individual observations such as sea surface temperature, currents, but we look at these as an integrated picture. And in order to do that, we need to better understand how we can bring together our data with our models and have open science, open ways to share information, both the data itself as well as the models. And so with Goddard, our focus is on how we can innovate Earth system science, focusing on innovation, integration, and informing for impact. And that really is what we're doing looking forward, is trying to combine all of these different aspects. So what I'd like to do is talk you through some of the examples. The first is the data that drives our understanding. And so what you see here are different satellites, as well as you can see aircraft, you can see ground-based networks, and all of these form this fabric that we need to understand Earth as an integrated system. And so you see flashes from our geostationary observations that are run by NOAA, and you see the orbits, but fundamentally we need complex modeling systems to be able to bring this information together. And in order to bring it together, we need to kind of combine different types of observations. And so what you see here is actually a fabric. We call it the Earth breathing. And so this is looking at our Earth's oceans. So this is looking at chlorophyll in the oceans. You can see productive zones coming off of rivers. You can see more dead zones in purples where we have descending air. And then on land, you can see the movement of ice and snow as it makes its southward journey in the Northern Hemisphere into the United States and Asia. And you can see the greening up of Africa. And why are we looking at this all together? Well, we know the integration of precipitation with vegetation information, and then how that impacts runoff and chlorophyll content in the oceans for productivity of fisheries, et cetera, is vital. And so we have a new mission coming up called PACE, which will start to look at, in most detail that we've ever had, at the health of our oceans and understand the linkages with our land surface. Another part of our atmosphere and our surface that we are seeking to continually understand is looking at the Arctic. And we know that the Arctic sea ice has been continually changing and decreasing. The minimum extent as well as the thickness has changed over time. And so we have satellites such as the ISAT and ISAT-2 missions that are allowing us to better understand using altimetry data, the strength, if you will, of those Arctic areas and understanding the feedback loops that it causes for climate. And then a mission that's very close to what I've been doing over the past decade and a half is looking at precipitation. So connecting these behaviors in our oceans and our Arctic with an understanding of where and when it's raining and snowing around the world. Now, the Global Precipitation Measurement Mission has been co-led by NASA and the Japanese, the Japan Aerospace Exploration Agency, and it leverages not only a satellite with the most advanced instruments to measure precipitation from space, but it weaves together information from other satellites around the world to really get a sense of where storms develop, where these big systems may move. And this is critical for weather forecasting, as well as other understanding of phenomena. So I just pulled this yesterday. This is the last 7 days of rainfall. You can see the remnants of Hurricane Fiona that actually was skirting the coast, and now you see Ian developing, excuse me, as it's making its way into the Caribbean, and unfortunately is at this time hitting our state in Florida and going to be causing some significant damage. You can see the evolution of these storms. But not only that, this is Hurricane Fiona. What we can understand is looking at the rainfall totals, but we can also see the three-dimensional view of these storms. And so this is the first time we've been able to do this from space this far away. So this is Hurricane Fiona as it was moving off the coast. You can see this well-defined eye of the storm. You see the rain bands coming, and then the blue is actually snow at the top of hurricanes. And understanding how high these storms are, over 10 kilometers in height, is critical to understanding the rapid intensification processes. These are the information that we really need to improve forecasts in terms of how impactful the storms may be. But also understanding rainfall totals is critical to looking at inland coastal flooding, coastal and inland flooding, et cetera. And so this vantage point is quite unique to be able to harness this information to improve forecasting. I wanted to take you to a different application of precipitation, one that Ben Zajac has been working closely on, maybe not in this region, but it's how we can couple precipitation with public health and understand kind of the correspondence between things such as Rift Valley fever outbreaks or malaria, as Ben has done in South America, and understanding where we have precipitation anomalies or wetter or drier conditions, and when the prevalence of, for example, Rift Valley fever in South Africa exists. And so we know there are very strong correlations between vegetation, precipitation, and temperature, and outbreaks of these vector-borne diseases, as well as waterborne diseases such as cholera. And so we work with researchers all over the world to better understand these, the connections between these and model these processes to hopefully improve lives and protect them from these terrible diseases. And another thing we can do is we can start to understand, or we continue to understand, how our land surface is changing. So this is a view of Landsat over 50 years, or almost 50 years. We now have 50 years of the longest running observation of our land from Landsat, which is co-led by NASA and the US Geological Survey. And this is a view of Las Vegas. And so you can see the growth. The red is vegetation. But what I would like to draw your attention to is actually the lake that's off on the right-hand side of this image. And so what you see is the lake is actually shrinking, and it's because of the water usage by the city and the needs that it has to support its growing populations. And so we see this all over the world, not just in our surface reservoirs. We have a mission that we're working on with the French soon called SWOT, the Surface Water Ocean Topography Mission, and that will help us understand the state of our reservoirs and land. But we also have missions such as the GRACE follow-on and GRACE missions that help us understand underground reservoirs and looking at the pervasive droughts that cause decreases in the underground reservoirs, and on the contrary, looking at floods and overly wet areas. So together we get a much better understanding of water resources and how this water is moving and impacting us on land. And another way we can view this and how it's used in operation is by looking at the status of our droughts. So this is from the US Drought Monitor. This is a partnership that we have with the University of Lincoln, I believe, of Nebraska. And so we are, they're using information such as GRACE, which I described, and other data to better understand drought situations. And so what you see is there are parts of the US that are, as of last week, in extreme drought or severe exceptional drought. And this is a huge concern for things like wildfires and understanding where there's pervasive dry conditions that could exacerbate fire conditions. So how we do that, and this is an example that I always like to show. Let's see if I can, oh, there we go. There we go, is using a model called the GEOS model, and this is developed by our Global Modeling and Assimilation Office. And so what you can see here is that with a model where we bring in or we assimilate data, we can start to understand the big processes that are happening. So if you look at Australia, you can start to see the wildfire smoke. This is from 2019, and how far that smoke and aerosols transport. So what you're seeing here are several different kinds of aerosols. You see smoke, you see sulfates, and you can see dust coming off of Africa. And so the dust, for example, forms the nuclei, the starts of hurricanes that we're experiencing right now in the United States. And then you can see the air pollution and how much from some of these pollution sources the air can travel to negatively impact air quality in other places of the world. So because we are all intrinsically linked, we need to think as a system. We can't think individually into single observations. And that's really the goal of not only what we're doing, but how we approach partnerships. And so looking forward, this is a view of what we have coming up and what we have flying. And so you can see there's key international partnerships, and the orange color shows what's about to fly. Fortunately, we do have Landsat 9 that was launched, and we're working on tropics. And then next to come up is NISAR, which I'll just talk about briefly, into kind of this next group of Earth science satellites that will help us understand our Earth for the next decade and beyond. And so I wanted to speak a bit about the NISAR mission, the NASA ISRO SAR mission. And so NISAR is set to launch in early 2024, and it will measure the Earth's changing ecosystems, surface dynamics, ice sheets, etc. And it can look at everything from natural disasters to water resources. And it is a dedicated US and Indian INSAR mission. And this is in a close partnership to really understand global environmental change. And so this was signed, this is our former administrator in 2014 by Charlie Bolden and the ISRO chairman. And so we signed these documents to work together in building this very complex and highly impactful mission. And I encourage you to go to nisar.jpl.nasa.gov to highlight more of this work, as you can learn a lot about the science behind it, the white papers and applications. I wanted to highlight just a couple of examples. One is going back to the Arctic and looking at how glaciers, ice sheets, and oceans change. So essentially the synthetic aperture radar is an active system. It sends out pulses to understand changes in deformation of the surface. And with that, it can actually look at ice flow. Over time, it can get a sense of how ice is moving, how glaciers may be calving, and the velocity of some of these movements. And this is important for sea level rise, and as well as projecting out what some of the impacts may be as a result of warming. Another example is looking at volcanic hazards. And so NISAR will look at the deformation around volcanoes to understand some of the world's most active volcanoes that aren't routinely monitored, and get a sense of how we may expect either explosive volcanism or kind of more subdued volcanism, but either way, they're very important to understand how they may impact populations proximate to that, as well as the potential for impacts of air quality, aviation, et cetera, downwind. And so we're really excited about this mission. We're excited about the potential, and we look forward to figuring out how this data, which will be in terabytes per day, can be harnessed with open science principles to better understand these processes across this landscape. And I just want to close by talking a bit about what's coming up. So the Earth System Observatory is how NASA is looking forward in Earth science towards our next decade. And it combines different observables based on what the National Academy of Arts and Sciences has developed a study that was published in 2018 that highlights these key observables as what we should look at for the next decade. And those include clouds and convection, precipitation, aerosols, mass change, understanding the surface movement and deformation, and then looking at the surface biology and geology. So one of the missions that I've been focusing most on is the atmosphere observing system. And this couples information from precipitation as well as aerosols to better understand air quality, the formation of storms and how they intensify, and the convection within them. So if you connect NICAR's observations of volcanoes to the smoke and the aerosols that come out of, and the particulates that come out of volcanoes, you can see how we start to form this integrated picture to understand the individual particles as well as this bigger picture. And so looking at kind of the different applications of this type of information, these include weather forecasting, air quality modeling, logistics, even solar energy, looking at radiation. And so this is really important for our next decade to better understand these key science observables to make an impact for populations. So I'd like to end with this information on what can we do? I think there's so much information out there. There's so many important training programs, such as the Applied Remote Sensing Training Program, RSET, which allows people, thousands of people around the world in many different languages, to engage with this data and get hands-on experience. Everything is free. And so there's so many ways to be informed. Looking at the climate.nasa.gov has these signatures to understand the different aspects of how our Earth is changing using satellites and model picture. We can also be involved. So in addition to training programs, there's citizen science, there's internships, allowing us to interact not just with, for example, Earth science, but to get involved in astrophysics, finding exoplanets for where water may be and life in other galaxies. And finally, so one example I should say is in my own research is looking at landslides, an area just focused on India that you can see where we know there are significant landslide issues, and we're building models to understand using precipitation that we introduced along with surface information to better improve and ultimately forecast potential landslide hazard areas. And we need more data. So adding landslide information helps us improve our models. And then finally, this is one of my more favorite visualizations. We want you to be inspired. There's so much out there that it can be overwhelming, but fundamentally, even looking at very, very local issues is critical to really understanding that bigger picture. And so this is an example of the 2017 hurricane season. You can see the dust storms coming off of Africa. You can see how the sea salts from storms like Irma, how that's forming from the nuclei of these dust events, and how those start to form and impact us in a different continent. And so we know that we're all connected, and so I encourage you to be involved and to continue these important partnerships, because we can't do it alone. It's an all hands on deck approach to understanding how our climate is changing. And so we look forward to engaging and figuring out how we can all do this together. So with that, thank you so much for having me. I'd be happy to take questions if there's time. And I wish you a very successful inaugural meeting. So thank you so much.
Dalia, thank you so much for being here this morning and this afternoon in India. Really appreciate it. Your inspiring remarks. And I'm sure there will be follow-up, even though we don't have time for questions right now. So thank you again.
Thank you so much. Bye-bye.
Thank you so much. And so I believe I'm handing over now to Dr. Nitish Dogra to introduce our next keynote.
Hello. Hi, Ben. It gives me great pleasure to introduce Suruchi Bhadwal, who's Director of the Climate Science Division at TERI. Just a very brief introduction for her. She has done her master's in environmental sciences and has since then been working in the field of climate change. Her focus has been mainly on impacts, vulnerability, and adaptation assessments, working in close association with the communities. Some of the projects worth mentioning relating her involvement include a study on vulnerability to climate change in the Indian agricultural sector in the context of economic globalization, a study supported by the Canadian International Development Agency and the government of Norway, contribution to India's first and second national communications submitted to the UNFCCC, and a World Bank supported study on vulnerability to climate variability and change through an assessment of issues and options for adaptation. She's also listed as a UNDP regional roster of expert on vulnerability and adaptation. And what she has not mentioned is the fact that she was on the scientific panel at the time when IPCC got the Nobel Prize in 2007. So over to you, Suruchi.
Okay. Thank you so much for the opportunity. I'm very glad to deliver the keynote address for the inaugural annual conference of the Johns Hopkins Gupta Kensky India Institute, and joining Dr. Kirschbaum in this session, who has highlighted the excellent work being coordinated at NASA. The Energy and Resources Institute, from where I belong, which is very popularly known as TERI, is a lead institute in the developing world, headquartered in Delhi in India, leading work on energy and environment issues, with a 3-decade contribution to work on climate change, with a focus on advancing science and understanding the impacts, vulnerabilities, and adaptation, and also focusing on GHG mitigation and linkages to SLCPs, short-lived climate pollutants and air pollutants, overall basically trying to study the implications of these changes in the environment to various sectors, including studying the impacts on health. The pandemic has highlighted how vulnerable we are in an era of increased interconnectedness, technology advancement, and multilateralism. Health has been a primary focus for all obvious reasons in the last few years, and we all realize it quite well. The G20 presidency, therefore, has recognized the importance, and for the last 5 years, the H20 summit, which is the G20 Health and Development Partnership, has brought together global health thought leaders and stakeholders from around the world to deliberate on various aspects, highlighting yet again the need for strategic investments in health research and improving access. The COVID-19 pandemic has been far more than a health crisis. It has deepened economic, social, and health inequalities. It has made clear that health is central to development. Concurrent challenges of conflict and humanitarian crisis, deepening poverty, rising food energy prices, increasing nature of climate impacts continue to be concerning areas, apart from what we've already been experiencing on the health front. Climate change has been one of the most pressing challenges to humanity. It has implications on the social, environmental, and health aspects of the human community, right from impacting food and water security and biodiversity to hampering human health and well-being. We observe how climate change influences us and our existence. In the last 2 decades, the impacts of natural disasters have been devastating. And in the previous keynote address, you could see what kind of efforts are being put to understand the science behind all this, which basically lets us know how vulnerable and exposed we are to the consequences of these changes. We have data and statistics which basically tells us that over 4 billion people were affected in the last 2 decades due to natural disasters, with mortality rates of nearly 1 million and about $2.9 trillion economic losses. Climate hazards are increasingly contributing to a growing number of adverse health outcomes in multiple geographical areas. Increase in the spread of diseases to new locations, for instance, the Lyme disease vector in North America and tick-borne encephalitis in Europe, spread of malaria to new areas are causes of concern. Increase of diarrheal, other gastrointestinal infections, and foodborne diseases, respiratory tract infections are other areas of concern. Climate change has adverse impacts on well-being and threatens mental health. Several chronic non-communicable respiratory diseases are climate sensitive based on their exposure pathways, example, heat, cold, dust, small particulates, ozone, and other allergens. Worldwide, rates of adverse health impacts from ozone air pollution exposure have also increased. Exposure to wildland fires and associated smoke, pollen, heat, and its impacts have also been on a rise. Climate change is projected to significantly increase population exposure to heat waves and heat-related morbidity and mortality. Climate-related illnesses, premature deaths, malnutrition in all its forms, including undernutrition, overweight, and obesity, and disease susceptibility are increasing. These impacts are strongly mediated by socioeconomic factors, and we are not left behind, coming from India. Extreme climate events contribute to migration and displacement. The largest absolute number of people displaced by extreme weather events each year occurs in Asia. If you look at the statistics, it's enormously high. Compared to the international migration that is observed from Asia, I think internal migration is turning out to be a big issue. And the implications on health and the linkages that we see with regard to the quality of life is a big concern. A significant increase in ill health and premature deaths from climate-sensitive diseases and conditions is projected due to climate change. India, being a vast country with multifaceted geography, cannot be generalized in terms of the effects of climate change. They differ substantially across different regions and across different social strata and population. India is extremely vulnerable to the impacts of climate change. We have observed an increase of nearly 0.8 degrees Celsius rise in temperatures since the pre-industrial times. We have experienced extreme rainfall events, and consecutive flooding has increased multifold. The trend of decrease in the rainy days and increase in temperatures has been increasing over time, and the exposure to droughts are being experienced in many parts of the country. Climate change affects the social and environmental determinants of health, clean air, safe drinking water, sufficient food, and secure shelter. Areas with weak health infrastructure basically are the least able to cope with and prepare and respond to the consequences of these risks that we are talking about. Climate impacts on health on an already impoverished population are quite stark and in many cases not well understood in the country. Climate change impacts on vector and waterborne diseases, heat stress, respiratory and cardiac impacts further increase the disease burden of the population. Direct impacts of extremes increasing, the mortality and morbidity rates are being observed. Malnutrition is one of the topmost factor driving disease prevalence in India, followed by wash-related diseases and incidences of vector-borne diseases like malaria and dengue and chikungunya. There are also other newly emerging diseases, re-emerging diseases like the KFT disease, which has hit the southern states of India, and other aspects including the linkages with air pollution. Together, what we observe is ambient and household air pollution have been responsible for 7 million premature deaths in the year 2016 in India. Of these, more than 5 million deaths have been due to non-communicable diseases like heart diseases and strokes. In 2016, 16% of these deaths in the country were between the age groups of 30 to 69 years, clearly attributed to air pollution that we experience in many cities of the country. Effects of climate change on public health, coupled with the impacts of extreme events and hydrometeorological disasters on health and related resource systems, is a key concern for resilience development and disaster response preparedness in the country. The direct damage costs to health, excluding costs in health determining sectors such as agriculture and water and sanitation, is estimated to be between $2 to $4 billion per year by 2030s. In the face of these challenges, what we basically conclude is countries need the support to move forward on the path to ensuring universal health coverage and meeting other health-related targets to promote global health goals. The scope of multilateral agreements in this context needs to be explored. However, the challenges with implementing these agreements are well evident and highlighted during the COVID pandemic, which exposed systemic weaknesses in the ability of societies to anticipate and respond to global risks. With proactive, timely, and effective adaptation, many risks for human health and well-being could be reduced and some potentially avoided. Building climate-resilient health systems will require multi-sectoral, multi-system, and collaborative efforts at all governance scales. Reliance on historical climate conditions will no longer be tenable since climate change generates conditions well outside past parameters for current and future planning. Lack of data in health has hindered understanding of climate change and health issues in the country. Filling of these knowledge gaps, health sector resilient services and delivery systems, strong infrastructure and institutional mechanisms, and ways to metabolizing finance are needed to build resilience and basically require support both from the public and the private sector. Investment in R&D, development of appropriate technologies for simulations, including early warning systems, is strongly felt. So some of the work that we saw NASA basically showcased with regard to what it has been doing with regard to simulating different events and studying different impacts would be very crucial for any country to look at, and therefore the capacities of countries need to be built with regard to those assessments and understanding those assessments to be able to take it forward for policy and action. There's a need to develop a network program to generate health data and evaluation across the country, but also international partnerships with like organizations, like NASA, to be able to share the knowledge and its learnings with regard to these areas of work. Institutional capacities, innovation, and coordination is needed, and standard operating procedures to help promote implementation and ensure targeted health service delivery. Strengthening these healthcare systems and health sector and community risk preparedness are the call of the day. Documentation of traditional systems of cure and management is also needed because India is basically a society where there's a lot of traditional systems, local indigenous knowledge that exists with regard to certain areas. And therefore, one needs to explore those areas as well to see if they are relevant, and two, if we do see potential for scalability. Incremental changes in policies and strategies have proven insufficient to highlight the value of more integrated approaches and frameworks for solutions across systems and sectors, and urgent action is thus needed to support countries to address these major health challenges and strengthen global health security. Combating pandemics will naturally dominate the global agenda in the coming days. The interdependent nature of our life means that no one is safe till everyone is safe. If there was one occasion where the limitation of purely national actions was visible, it was in the response to COVID-19. India proved to be a global leader by providing assistance during the pandemic through medical supplies and equipment that have been provided to more than 150 nations, and many of them were in the form of grants. The world can not only benefit from a more collective effort to deal with these such serious issues that we're talking about that confront us, and therefore we also call for a global program and partnership and collective effort with regard to climate change and health concerns that possibly institutions and countries need to come forth. India has also led to major international initiatives. We have set up the International Solar Alliance and the Coalition for Disaster Resilient Infrastructure, strengthening partnerships for response on climate actions. A stronger consensus of seriously addressing the climate change challenges has obviously its own implications. The Government of India has a vibrant national program on climate change and human health, which is in its implementation stages and is in the process of taking shape. The focus of this program is multifaceted with the objective of raising awareness, supporting research and development, building institutional capacities for better response mechanisms. A few areas with regard to addressing health concerns that matter for us include creating conditions for good health and well-being, strengthening primary healthcare systems in the country, protecting health by strengthening the global architecture for health, emergency preparedness and response, exploring multilateralism, partnerships in moving this agenda, and powering health through science, research, innovation, data, and digital technologies. We will need to focus on policies and initiatives on rebuilding and revival. At the end of the day, we all live by our beliefs, values, goals set in life. There are challenges that are evident. Working together in that regard is important as on all other global issues. We have a shared interest and collective obligation to make our planet a better place to live in. I do wish you fruitful discussions in the course of the session. Thank you for your attention, and I do look forward to any questions that the audience may have. Thank you very much.
Thank you very much, Suruchi. I handed it over to the chairs of the conference to take it further. Thank you.